So far, we've been working with identifying the different properties of a trig function in a graph. We've been looking at amplitude, midline, vertical shift, and being able to identify that. Now, we're going to take a look at being given a graph, if we can find the parameters a, b, and c, and d of our equation written out. So our learning target is I can solve for a missing parameter in a trigonometric function. All right, so before we begin, I'd like to point out that there are some easy things, and let me just slant my paper here, that we can work with. So some easy things that we can work with. And what I mean by easy is that your amplitude is basically one that we could tackle out the way first. So in order to find amplitude, my usual steps is first identify the midline. So here's my midline in my trig function. And the amplitude usually involves counting from the midline up to a maximum. I'm going to go ahead and count. So between -4 to 3, that measures as 1 unit. So I want you guys to remember that amplitude is always positive. So my A term is going to be +1. Next, I'm going to shift down to our vertical shift. By the way, if it helps, you could put what it means right next to it. So next, I'm going to be moving into vertical shift. Vertical shift from my directions is basically where your midline is at. So I've already identified my midline being right here at -4. So my vertical shift is just -4. My D is just going to be -4. We've already identified two parameters. Now the ones that involve work are basically B and C. So let's go ahead and try to tackle how we find B and C together. All right. In order to find B, what I do know is that period involves the formula 2 pi over b. So I'm going to write down that piece of information. So I know that 2 pi over b is equal to period. So I'm going to put is equal to p. Now let's see if I could find some other piece of information. If I know my period, then I could solve for the unknown parameter b. So let's see what my period is by looking back at my graph. Now let's review the steps to find the period of a function, of a trig function specifically. In order to find the period, you identify two consecutive maximums. You could also do minimums, but I'm going to just always be doing maximums here, just so that I can maintain consistency. The two maximums that I want to choose are right here. I'm going to use these two. If you all remember, period is where you count the boxes, or the distance between 2 points of the maximums. So let me go ahead and count the distance, and I'm going to do it by counting boxes. So I have 1, 2, 3, 4. The distance of boxes between my two maximums is 4. So I'm going to go up to my x-axis, start from 0, and I'm going to move to the right by 4 units. So 1, 2, 3, 4. The number that I land on right here after doing those steps is pi. Therefore, my period is pi. So what I'm going to do is this is going to become pi. Let me just write my next step right here. So 2 pi over b, period, is equal to pi, because that's what we just counted. Now the question remains, how do I solve for b? What we can do is we can put this over 1, and then we can cross multiply. If we do that, we'll be able to solve for b. So then b times pi is going to be pi b. 2 pi times 1, that's just 2 pi. So now I have this nice setup of an equation. In order to get b by itself, what I'm going to do is I'm going to divide both sides by pi. The pi's will cancel out, and I'll be left over with b is equal to 2 pi over pi. Now you notice that I could cancel out a common term. I could cancel out the pi's. By the way, guys, pi represents 3.14. It's a number, so it's something that we could definitely cross off and work with. So what you're left over with is that b is equal to 2. Yay, we found our second parameter. B is equal to 2. So that was a bit of a process that you had to go through here. So you want to follow that process. All right, let's take a look at C here. Now, how do I find C? Now, if I was to look at my little pink formula sheet that I handed out to you all, um, in it, it says the phase shift formula is C over B. So I'm going to be using that component to solve for B. I'm sorry, to solve for C. So I know that, and let me just try to organize my work here. So this right here was for B. Let me just draw a box there so I don't mess up my stuff. There we go. So that's just for finding B right here. All right, so now to find C, I'm going to be using the formula C over B. Write it up here. Okay, so phase shift, right? Phase shift basically represents how my function is moving either to the left or right. Because this is a sine function, so sine graph, what I'm going to do is I'm going to go look at my notes. I'm going to look at the parent function for sine. This is the parent function for sine. Notice how the parent function for sine starts at 0, and then it just goes, right? So that's where it starts, right? And now let's go ahead and compare it to over here, the picture right here. So basically it starts right here. It doesn't start at 0, right? But it didn't move side to side. There was no horizontal shift. This was shifted down by 4 units, but there was no side to side movement. Therefore, because there's no side to side movement, C over B is equal to 0. And again, that was because I was looking at my parent function and seeing, did it switch from where it started? And it didn't. So my phase shift is going to be equal to 0. All right, so from there, let's see if we could solve for C. What I'm going to be utilizing is the fact that I already found B. See, B right here is going to be equal to 2. So let's go ahead and substitute that. So it's going to be C over 2 is equal to 0. I'm going to do my usual steps here. So in order to solve for C, let's do some cross multiplication. Let's put this over 1. We're going to cross multiply. 2 times 0 is just going to give me 0. And then C times 1 is just C. Therefore, my C is equal to 0. And again, let me reiterate, because there was no side-to-side movement in the sine graph. Again, this was my parent function for sine. It did not move side to side. It only moved downward by 4 units, but that's accounted by the vertical shift there, not by the horizontal movement. So that one's example 1. And, well, not done yet, right? We actually got to write out the function now. So this is the standard form. Again, this is looking at your notes right here. See the standard equation of a sine function. So let me just rewrite it right here. All right, so my equation written out. So my A was 1. My B was 2. C was 0, and my D was minus 4. Now, we would not write it like this on IXL. We don't usually write times 1 in the front. We just write it as sine. And then 2x plus 0, we don't write plus 0. We just do it like this. And then we just put our minus 4. So this is my actual answer after I simplify those variables. So that is example 1 fully finished. You do want to make sure you review this, but we're going to go ahead and repeat our process for example 2. Example 2 will be having a phase shift. So we're going to be taking a look at that one. So that's going to be interesting. So I'm going to fold my paper here so that we can look at example 2, even though this is kind of still leaking out there. So here we are in example 2. So we're looking at a cosine function now. So that means when I'm referencing my phase shift, I'll be looking for cosine, which is right here in the bit. So this is from our notes. This is page 1 of our notes that I'm referencing right here. So in a second, we're going to be using this. All right, let us start off with the basics. So first, let's find amplitude. Amplitude is the easiest for me to tackle, so I'm going to do that first. Again, let me repeat the steps to find amplitude. Step 1, identify the midline. The midline of this function goes right here on the x-axis. All right. Step 2, we go ahead and from the midline, I count up to a maximum. I'm going to choose this one. You could have done this one, but I'm going to just choose this one. So from 0 to 1, it looks like my amplitude for this one is also 1, so I'm going to put 1. All right. Now, let's go ahead and tackle vertical shift, which is my D term right there. Vertical shift is basically where your midline is at. Well, my midline was at 0 here, so therefore my vertical shift is 0. Right, A and B are taken care of. Now, let us go ahead and find B. So again, because this is a cosine function, the period for cosine is 2 pi over b. So I'm going to be using 2 pi over b and go right here to the side. So 2 pi over b is equal to my period. But again, what is my period? Let's find out by using my graph. So again, in order to reiterate how we find period of a function, we identify two maximums and you count the distance between the two maximums. So let's count our boxes. So we have 1, 2, 3, 4. Then from there, you go down to 0 on the x-axis and you count 4 units to the right. 1, 2, 3, 4. It looks like my period is going to be 2 pi. So let's go ahead and set up this equation right here. So 2 pi over b is equal to 2 pi, because that's the period I just found. Now, let me repeat my process. So in order to solve for b, I'm going to put this over 1, and then we're going to cross multiply. So b times 2 pi is going to be 2 pi b. And then we have 2 pi times 1 is just 2 pi. In order to solve for b, the parameter b, we're going to divide both sides by 2 pi. That way this goes away, this goes away. You get 2 pi over 2 pi. Anything divided by itself is 1. So there we go. I solved for b. b is just 1. This is looking very nice. So b is 1. So I'm going to go ahead and again box away my work just so that it's not all jumbled up for you. And then we can work on finding the C of this equation. All right, so now let's use some information. So on my pink resource sheet, I know that phase shift is equal to C over B. So then I'm going to go ahead and put C over B is equal to phase shift. Okay, now we need to find out what the phase shift is for this cosine function. So this one does have a phase shift, and this one we're going to be looking at our parent function for cosine. Okay. So we're looking at, here's our parent function for cosine. I noticed that it starts right here on its maximum. It starts right there on the x, on the y-axis there, right? So let's go ahead and see where the first maximum of this cosine function is at, after 0. So after 0, the first maximum is right here. Notice how it doesn't start where the 1 was over here. It shifted to the right, right? How much units did it shift to the right? Well, it looks like it's down here. It shifted about pi units to the right. So it went to the right by pi units. To the right by pi units. See how that shifts happens? Because this is a cosine graph. It's supposed to start right here, but then it got shifted to the right by pi units. So it's actually starting right here, like this. So this is me just drawing on the parent functions. It's very crooked, but basically it's shifted to the right by pi units. So that one might be take you a little bit of practice to understand how we just, seeing the shift happen. You have to look at your parent graph to determine that shift. All right, so then if it's shifted to the right by pi units, we're going to go ahead and make this equal to pi. Now, phase shift does have that thing where the sign becomes opposite. So we're going to take care of that in a second. All right, let's go ahead and try to solve for this now. Now I know that b is equal to 1, so let's go ahead and do c over 1 is equal to pi. Now let's do pi over 1. We're going to cross multiply. C times 1 is c. 1 times pi is pi. So that means c is equal to pi then. So c is equal to pi. But what's the sign, right? Let's take a look. So because it moved to the right, that's like moving in the positive direction. Therefore, in our equation, you're going to have a minus inside the parentheses. Let me go ahead and write down my cosine parent function, standard form right here. So basically this plus is going to be a minus because when it shifts to the right, that means it's a minus. If it were to have shifted to the left, it would be a plus inside the parentheses. So that's how the oppositeness is coming in here. So my A was 1, my B was 1, my C was pi, but remember minus pi, when it moves to the right, it's going to be minus, and my D was 0. Simplifying all of this out, it's going to become cosine of x minus pi. We don't write plus 0, and again, we don't write these little ones. Usually those are the imaginaries. And that is your equation. All right. Let's do one more. And then once you're done with it, I do want you to try out example 4 on your own. So let's see. All right, so this one, let's go ahead and tackle the easy stuff. Amplitude first. Okay, in order to find amplitude, first find the midline. It's at 0. Next, count up to a maximum. I'm going to choose this maximum. So from 0 up to 2, this looks like it's 2 units. So my amplitude is 2. Remember guys, amplitude will always be positive. Next, let's take a look at vertical shift. Well, remember guys, vertical shift is basically where your midline's at. Because my midline's at 0, vertical shift is 0. Alright, now let's go ahead and try to find B. So my B, the formula that it comes from is from period. So I'll be using 2 pi over B is equal to period. What is my period for this function? Let's find out. The process for finding periods, you identify 2 maximums. You're going to count the boxes between them. 1, 2, 3, 4. You're going to go down to the x-axis, count 1, 2, 3, 4. The period for this one is going to be 2 pi, therefore. We're going to put this over 1. We're going to cross multiply. So you get 2 pi times 1 is 2 pi. 2 pi times b is 2 pi b. And then to solve for b, you're going to divide both sides by 2 pi. So this is going to become 1 because anything divided by itself is 1. So we got that b is equal to 1. Awesome. I'll just separate my work for b right here so that I can show you guys how I find c. Alright, now phase shift. So let's see. This is a cosine graph. So let me look at my parent function to see if it's shifted anywhere. Let's just ignore this previous work that I did. Alright, so parent function's right here. It starts right here. And it looks like there is no side-to-side movement. Both of these graphs start at the same location horizontally, right? So there was no side-to-side movement of this point right here, of this maximum point. So therefore, the phase shift is going to be 0. So that's nice. Phase shift is going to be 0. That means C over B is equal to 0. I know B is equal to 1. So then that's C over 1 is equal to 0. Put this over 1, cross multiply. So C times 1 is C. 1 times 0 is 0. My C is equal to 0. No phase shift. Okay. So that means this function right here is going to be nice and easy for us. Let me write out the cosine parent function. A cosine bx plus c plus d. Alright, so my A is 2. It's going to be, my B is 1. My C is 0. my d is 0. Simplifying these out is 2 cosine. We don't write the 1. No, don't write the 0, don't write the 0. So my function is just 2 cosine of x. All right, so now what I want you to do is to figure out how to do example 4. So example 4 is a cosine graph. Sorry, my camera's crooked. Cosine graph. Again, if you want to, one of the most difficult things is phase shift, honestly, because you want to look at how the original function shifted from side to side. And usually I like to look at where it starts. But anyways, that's for phase shift. So you guys can go ahead and compare whether this cosine graph shifted from its parent function side to side. That would help you with your phase shift. All right. So please, once you're done attempting number 4, you want to raise your hand. Otherwise, we might be going over this as a class if I see that we need that support. All right. Thank you all.